Hello, everybody. Welcome to section 1.7, Modeling Word Problems, Part 2. Today, we're going to be covering like time needed for job problems and distance, speed, and time problems. So let's go ahead and just get started. So first off, let's start with a time needed for a job problem. So this one right here is time needed for a job. Right, and so the problem we have here is a plumber and his assistant work together to replace the pipes in an old house. The plumber charges $45 an hour for his labor and $25 an hour for his assistant's labor. We know that the plumber works twice as long as his assistant on this job, and the labor charge on the final bill is $4,025. How long did the plumber and his assistant work on the job? So there's a lot of numbers here, as usual with word problems. So let's just write down what we know. So we know, first off, the plumber charges $45 an hour. And then the assistant charges 25 an hour. Cool. And we also know that the plumber works twice as long as the assistant. So, so we know plumber hours are like 2 times assistant hours, right? And then lastly, we know that the total bill was $4,025. Cool. And what do we want to know? We want plumber hours. So I'm going to denote that with P, so plumber hours. And we also want A, assistant hours. So this word problem is a little tricky in the sense that we're actually trying to find 2 different things, but luckily we know that they're very related with this right here. So if we find one, we should be able to find the other pretty easily. So specifically, so if we write like this, especially this like important bullet point here in equation form, that's like, oops, P equals 2A, right? Because the plumber works twice as much as the assistant in terms of time. We also know that the total bill was 4,025, and that is going to be like however much the plumber works, right? So his $45 an hour times however many hours he works, plus $25 an hour for the assistant times however many hours the assistant worked, right? So that came from these right here, these 3. So now what I'm going to do is I'm going to take this P and I'm going to replace it with 2A. So that now I get an equation with only one variable, right? And if I distribute this 45 into here, I have 4025 equals, and then 45 times 2 is 90. Sorry, that was dumb. Not distributing it into there. There's no addition. It's just 90A. My bad. There we go. And then if we add these together, we get 115A. And now if we divide both sides by 115, we get A equals 35. Cool. So this, if you remember, A is the assistant's hours, right? So we know that the assistant worked 35 hours. We also want to know the plumber's hours. Remember, we have this nice little equation up here. So if we have 35 for A, we can plug in 35 right here. So then we get P equals 2 times A, right, which is 2 times 35, which is going to be 70. So we know that the assistant worked 35 hours. Plumber worked 70 hours. Cool. So that's that word problem. Time needed for a job, they're usually pretty straightforward like this. So let's go ahead and look at a distance, speed, and time problem. So, let's pull it up. There we go. Okay. So this one is distance, speed. Time. Now, the main key thing about distance, speed, and time problems, kind of similar to simple interest problems, is they have a formula that you can use. And it looks like D equals R times T, where D is distance, R is rate, so speed, and T is time. So whenever you're looking at a distance, speed, and time problem, you just know that distance is just speed times time, right? So if you just remember this for these kind of problems, it'll serve you well. So looking at our word problem here, we know that Kieran drove from Tortuga to Cactus, a distance of 250 miles. She increased her speed by 10 miles per hour for the 360-mile trip from Cactus to Dry Junction. So let's draw this a bit, because sometimes, especially distance problems, are very nice to draw pictures for, right? So we know that she started in Tortuga, and she went to Cactus, and then after that she went to Dry Junction, right? And so we know that the distance for the first trip is 250 miles, and the second one is 360 miles, right? And we know that if this right here is speed x, this is speed x plus 10, right? Because she increased her speed for like the second half of her trip by 10 miles per hour. So we know that also the total trip took 11 hours. So total time, 11 hours. And then we want to know what was her speed from Tortuga to Cactus. So we want this speed right here. So we want x speed. Right. So you may have noticed just right off the bat that unlike simple interest problems, these can be a little trickier in the sense that we're not just like plugging numbers into this equation. More like the equation is a good tool to kind of translate between speed and distance and time, right? So if we know that the total time was 11 hours, what I'm going to do is I'm going to let T1 be like the time of the first half, right? So the time it took to go from here to here. And I'm going to let T2 be the time of second half. And so we know that T1 plus T2 should equal 11 hours, right? Because the total trip took 11 hours worth of time. But now this is where our formula comes in handy. So we know that D equals RT. We can always rewrite this by like dividing by R, dividing by T. So we can do some algebra and we can get that time equals distance over speed. So we can look at T1 and we know that this is distance over speed of like the first trip. And so we know the distance was 250 miles, right? Over a speed, so miles, over a speed of X miles per hour. And same thing we can do for T2. We get 360 miles over X plus 10 miles per hour. And so I'm just kind of like wading into the problem. I'm kind of writing down like the equations that I can, the equations that I know. I don't really have like a general strategy yet. What I'm trying to eventually get is one equation with just one variable, preferably X, so that we can just solve for X, right? And actually, we basically have it right now because now we've got T1 here. And so we can put it in this equation. And we also have T2 right here. We can put it in the equation. And we have them like in terms of X, right? So the only variable here is X. The only variable here is X, right? And so we can plug it in and we can write 250 over X. It's like the units kind of cancel, the miles here, plus 360 over X plus 10. And we know that all that's going to equal 11, and all this is in hours, right? Now this is an equation that we can solve, right? It's just a rational addition. So let's go ahead and solve it. So let's see, we have to make sure that the denominators are the same. So we're going to do times X plus 10, top and bottom, plus times X, top and bottom, all equal to 11. And then we can add these. So we get, let's see, 250X plus 10 plus 360X all over X plus 10 equals 11. Then what we can do is we can multiply both sides by the denominator. So on both sides, we're going to multiply by times X plus 10, X plus 10, right? So then these will cancel and we get 250 X plus 10 plus 360 X equals 11 times X plus 10. Cool. Now we can combine some more terms. So actually, let's first distribute. So we have this 250 distributes to there, and this 11X will distribute into here. So then what we get is we have 250X plus 250 times 10 is 2500 plus 360X equals, I'm going to write on the new line, I'm running out of space here. So we have 11X squared plus 110X, right? So now if we move everything to one side and combine like terms, we get 0 equals 11X squared minus 440 minus 250 double 0. So now this is a nasty looking quadratic. I would not recommend trying to factor this one. I would plug it into the quadratic formula, right? So we've got 440 plus or minus, and we've got, so this is, so actually, let's back up a little bit. Let's remember what the quadratic formula looks like before we start writing it down. So remember the quadratic form is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so in our quadratic here, a is 11, so that's here and here. B is negative 440, that is here and here. And C is negative 2500, and that's here. So we'll plug those in and we get negative 440 is just positive 440 plus minus square root. And then we've got negative 440 squared minus 4 times A is 11 times C is negative 2500 all over 2 times A, which is 11. And this is still pretty gross. And for this problem, I recommend just plugging it into a calculator. But don't worry, on your exam, especially, you won't need to use a calculator if you need to use the quadratic formula. So don't worry too much about it. But eventually, you get that x is approximately 45 miles per hour, or x is approximately negative 5 miles per hour. Now there's an or because remember, there's a plus or minus here, right? So there's two cases. And so now we've got these two answers, and one of them might look a little strange, right? So like this right here, x is a negative number. Remember, x up here, we were using it to mean the speed. So speed can't be negative because we're just going forward in this problem, right? So this one is impossible for this problem. So our answer is going to be this one. So speed for first half of trip was approximately 45 miles per hour. Cool. All right. That takes care of like the basic kinds of word problems we'll be doing in this course. Keep working on your homework and hope to see you in office hours.